Example 3. In example 3, we're solving the quadratic inequality negative 4x squared plus 5 is greater than or equal to 19x. The first thing we'll need to do is get 0 on one side of the inequality. So we must get 0 on one side of the inequality. So to do that, what I'm going to do is subtract this 19x from both sides so that I end up with 0 on the right. So that will give me negative 4x squared minus 19x plus 5, because I want to put this in standard form, is greater than or equal to, and 19x minus 19x is 0. Now remember that the solutions to a quadratic inequality are more than likely going to be an interval or the combination of intervals. So what we need to do is find the boundary numbers for those intervals, and the boundary numbers are going to be where this inequality is actually equal to 0. So to find the boundary numbers, what I want to do is solve the related equation. And by that I mean just take this and change that inequality sign to an equals. This one we'll solve by factoring. So I'm going to use the AC method. So remember, with the AC method, you're looking for two numbers that multiply to give you A times C, and that will add to give you B. Well, A is negative 4, B is negative 19, and C is 5. So A times C would be negative 4 times 5, which is negative 20. But they need to add to give us negative 19. So I always like to start with the 1 and the 20. So here I'm going to list factors of negative 20. So let's start with 1 and 20. Now, if it's going to be negative 20, one of these has to be negative. And if it's going to give us a negative number when we add, the larger one is going to be negative. And 1 plus negative 20 is, in fact, negative 19. So this is my pair of numbers that I'm looking for. So remember, what you do with that then is you're going to rewrite this original equation, but we're going to expand negative 19x using these two numbers. So I'll have plus 1x minus 20x plus 5, and that's equal to 0. So now I'm going to use the process of factoring by grouping. So if I just look at these first two terms, they have an x in common, and that will leave us with negative x plus 1. And then if I look at just these two, they have a 5 in common. I'm sorry, negative 4x. Forgive me there. Negative 4x plus 1. And then if I pull out a positive 5, I'm left with negative 4x again plus 1. So I caught my mistake, because remember that for this process of factoring by grouping to work, these two parentheses must contain exactly the same binomial. And so that's what clued me into I had made a mistake. So now if I look at it as this is a term and this is a term, they have the negative 4x plus 1 in common. And then what's left over is x plus 5. So what we have now is the factored form of this equation. And when it's in factored form, we can then solve it by setting each factor equal to 0. So negative 4x plus 1 equals 0, or x plus 5 equals 0. So that's going to give us negative 4x equals negative 1, or x equals 1/4. And then if we subtract 5 from both sides, that's going to give us x equals negative 5. So these will be our boundary numbers for the intervals of our solution. So now we have two methods to figure out whether our solution is going to be in between these two numbers or on either side of those two numbers. The algebraic method involves testing the intervals. So if I make a number line and I put the smaller one first, which is negative 5, and then 1/4, what I want to do is test interval 1, interval 2, and interval 3 to see which one of the intervals contain numbers that will satisfy this original inequality. And since the original inequality wants to know what values of x will make this greater than or equal to 0, that's another way of thinking this is we're looking for what numbers, when we plug them in, will give us positive answers. Because if it's greater than 0, it's going to be positive. So what we do is we pick a number in each interval. So let's say in this interval, I need a number less than negative 5. So I'm going to choose negative 6. And actually, the best place to plug it in is this factored form. So I have negative 4 times negative 6 plus 1. Sorry, it keeps erasing everything I write. And then negative 6 plus 5. And it really doesn't matter what the value is. What we're looking for is the sign. So negative 4 times negative 6 will be 24 plus 1 is 25, which is positive. Negative 6 plus 5 will give you a negative number, and a positive times a negative number is negative. So interval 1 will give us negative answers. So it's not going to be interval 1. If I look at interval 2, I need a number that's between negative 5 and 1/4. And 0 is in this interval. 0 is in the interval. That's the number I usually test with. So again, I have negative 4 times 0 plus 1 times 0 plus 5. Well, negative 4 times 0 is 0. 0 plus 1 is 1, which is positive. 0 plus 5 is 5, which is positive. And a positive times a positive is positive. So interval 2 gives us numbers that are going to be positive. Finally, if I look at interval 3, that's this interval over here, and a value that's greater than 1/4, well, let's use 1. You don't have to use a fraction just because your boundary number is a fraction. So that gives me negative 4 times 1 plus 1 times 1 plus 5. Well, negative 4 times 1 is negative 4. Negative 4 plus 1 is going to be negative 3, which is negative. 1 plus 5 is 6, which is positive. And a negative times a positive will give me, sorry, not negative, not positive, but negative answers. So remember what I said, I was looking for numbers that give us positive answers. So that would be interval 2. So that's where our solutions lie. So the answer to this quadratic inequality would be the numbers from -5 to 1/4. And since we have the equals to on here, and -5 and 1/4 were the values that made it equal to 0, then I'm going to put brackets because I want to include those numbers. Now let me just do a quick graph as well, just to show you the graphing method. And again, it does not matter to me which method you use. I want you to use the method that makes the most sense to you. So with the graphing method, the numbers that we found when we solved the equation, remember, are the x-intercepts of the parabola. So I'm going to put my x-intercepts on this graph. So I'll put -5 somewhere over here and 1/4 somewhere here. It doesn't have to be a perfect graph for these purposes. It can be a rough graph. Now I need to know, does this parabola open up or down? And so let me just jot these x-intercepts we found to be -5 and 1/4. And the parabola actually opens down because A is -4. And remember, if A is negative, the parabola is going to open down. So the parabola is going to do, whoops, let me draw that a little better, something like this. Now, it doesn't really matter that we get the vertex correct for these purposes, because what we're really looking for when we're solving a quadratic inequality is where the graph is either above or below the x-axis. And since my inequality was greater than or equal to 0, the values of y that are greater than or equal to 0 are going to be above the x-axis. So we're looking for the part of the parabola that's above the x-axis, which again is between -5 and 1/4. If this inequality had had a less than or equal to rather than a greater than or equal to, we would have used the parts of the parabola that are below the x-axis. So that would be from -infinity to -5 and 1/4 to infinity. So it doesn't matter to me. You can either plug values in and figure out where it's positive or negative, or you can graph it and see where the graph is above or below the x-axis. And that is the way, 2 methods you can use to solve a quadratic inequality.